Okay, we are recording. So welcome to our second online session. Great to see everyone here. We're going to practice working on concepts that were taught in lessons 3 and 4 today. We're going to use the text chat. So if you have questions throughout, please feel free to ask them in the text chat, or you can also raise your hand virtually, and I'll call on you if you have questions. Everybody has free range to their own microphones. So you can feel free to, use your mic and talk as well. Sometimes we find the text chat is kind of easier as we move on. If I am going too fast at any point, please just tell me. If I'm going too slow, just tell me. I love your feedback. I got some great feedback over the first online meetings. I really want to modify this based on your background. There's only 19 of you here, so let's make sure the session works for all of you as best as we can. Okay, so I'm going to move on to the overview. And the overview is going to be the same for every live online meeting. I want to make sure that you're moving towards developing proficiency in your knowledge and your application of that knowledge of R, and help you start speaking and thinking like programmers to some extent, specifically R programmers. And again, a lot of you may already have programming experience and have those skills, and so now you're just extending and transferring that knowledge to a specific syntax, which is R, and others are learning programming for the first time. So again, there's a range in this class, and that's what makes this MSBA class of about 70 students so unique. You're all from really interesting backgrounds and industries and locations, and also have lots of different knowledge about many different areas. So we're going to use the session 3 exercise. We're going to work from that today. And that there's a handout, and that handout is available in the materials section of the GoToMeeting panel. It just says session 03 practice exercise, and there's some data as well for you to download, the winterolympic.csv and the March Madness. You might have had some problems with this data file before, so you can use the one that you've been working with. That's fine, but you can throughout just make sure you kind of reference these materials so you can follow along. I'm going to give a brief overview of some of the concepts just to ensure that we're all kind of on the same page. So we talked about packages and installing packages and R scripts and importing data in lesson 3. And so I'm going to go over that again today. And I hear that there's some crackling in the audio, so I'm going to just go up to my attendees list and see if I have to mute everybody. So Emmanuel, I know that you came a little late. If you could just mute your microphone or your telephone, that would be great. Thank you. So before we jump into this overview, I'm just going to check the text chat and see if there are any questions. And I see one from Mark. And he asked, I have a question. We're submitting these exercises listed here or the ones in the assignment. It's a housekeeping question. Good question. So let's talk about exercises, things that we practice, you don't turn them in. Okay. Anything that we do in these live online meetings are really for your own benefit and practice. Every lesson in NYU classes 1 through 6 for the R portion of this course has an assignment associated with it. Please complete that assignment. And that's what you turn in. You can turn that in at the end of the post-module period. You can turn it in as you go. So if you've completed, lesson 3, then you should turn that in. And we will be giving grades and feedback on a rolling basis. So that's your incentive to kind of get things in. Then you'll get feedback, and you won't be kind of cramming and doing it all at once. They shouldn't take you very long. And I hope, many of you probably could attest to that as well. The lessons are designed to be like kind of 2 hours or, maybe 3 hours at the most, including doing the assignment. So, and these are lessons that have been pretty well tested. I've had, hundreds of students go through these already. So they've been modified several times. So hopefully this will They're really intended to optimize your learning and your time. So any other questions besides marks? No? Okay. A few of you have been sending me questions by email, and or our teaching fellow, Katie Walker. Please continue to do that if you have questions. And you can always attend a live session if you see that there's one on the calendar. At the end, if you have some questions and you just want to have a time to speak to me, that's a great time to just show up and ask some questions. Okay, so I began talking about packages. Who can tell me what a package is? You could write your answer in the text chat if you want to share. But for those of you who've gone through lesson 3, why do we talk about packages? They're not those things that, get delivered to your door. I tried Amazon Prime Now for the first time. It was very awesome. A collection of functions and data. Pre-made functions are scripts that can be installed, hold a bunch of functions. So remind me, let's then talk about what are functions. Yeah, Mark, I'm visiting Amazon Prime now after this class. I'm taking a group of students there, so I'm going to their distribution center at 34th Street. So my question was, what are functions? If a package holds a bunch of functions, if you have an answer or an idea, you can put in the text chat. A wrapper for a set of instructions, things you do to data, something that gives you extra abilities like data visualization. Okay, so, okay, these are. So let's talk a little bit about what I mean by packages. So when you go to the Packages tab in RStudio, you can see what's called your library of packages that are available for you to use and enable when you're in RStudio and programming. And there's a nice description, sometimes not so nice, like something like arrange globes in tables, and not everybody would know what that is. But for instance, you can see that there's some data visualization package, ggplot2, for instance. And this is a package, okay? And it says it's an implementation of the grammar of graphics. Well, if you didn't know what the grammar of graphics was, then that might not be that descriptive to you. But essentially what it is it's a set of functions and that act on objects. And those objects could be, entire data sets like data frames. It could be a single variable, and that allow us to pass in arguments using various functions to create, pretty sophisticated data visualizations. As an example, if we didn't have ggplot as part of a package that was part of our environment, we wouldn't be able to kind of create those visualizations. And each one of these packages is created by, someone. It could be a single person, it could be a community, it could be anyone who contributes freely to the R community and that are available for us to use. Some of these packages are updated all the time. So that's why this button check for updates is great. Some haven't been updated since 1987. So we need to be aware of that. Sometimes some packages overwrite functions that are available in other packages. For instance, there's a function called describe that's available in 2 packages. How does R know which one to use? So, and that's just kind of a poor design by the person who created a function by the same name of something that already exists. So you can learn more about the packages that you have installed. And these packages, think of these as like your capabilities. Okay, this is your toolkit of what you can do with R. And there's also a variety of data mining tools that you'll install as packages. And your professor, Louis Torgo, will have some packages that are specific to that you'll install once you take his class. I believe that's in the summer. So this hopefully gives you a better idea of what they are and why they're important. We can always install new packages. And today you might, and probably during the the course of this course, you've already had to install some that weren't just preloaded in your version of R. So here's just a general description, which is very similar to what many of you said. Package is a big collection of functions and other R objects that are all grouped together under a common name. Some are pre-installed and some aren't. And to find out at the command prompt, you can just type library. So I can demonstrate that for you. So I'll just go to RStudio and I'm going to clear my console. Okay, I'm just clearing my console here. And I would type library here. And you see, this is the library. These are all the packages that are installed in my version. Okay, so there might be some that you haven't used yet. Like maybe you haven't installed the psych package yet, or rcurl, or reshape. So there's many different ones that we will be using. And I'll always tell you what package you'll need to use. If you're ever curious about how to use a particular package and what functions are available, you could always, for instance, like ggplot2, I mentioned that graphics one, you can type at the command prompt !ggplot2, okay? And then on the right-hand side of the screen, you'll see in the documentation, you'll see, I don't know how many people have heard of Hadley Wickham, but he is the author and the maintainer of this. And he has like some really great books out too, all about tidy data. So you can read more about ggplot2 here. And there's also many different links that you can learn more about. Okay. And here, I just went to the index. You can see all of the different functions. Or sometimes these are parameters. So there's so many. And you would never be expected to remember all of these. But if I wanted to, say, create a bar chart, I could look at geom bar, and then down below, it will give me a sample of how I can create a bar chart. And you can work on this example. Okay. So I hope that's great. Yeah, I love Hadley's work too, John. All right. So I hope that's generally an okay introduction to packages. And packages are also thought of as libraries. And when we want to use one, and we have a few options. One is that we can go over here to packages, and if there's one that we want to use, and like, let's say, I'm just going to pick a one at random, knitr. Okay, if I'm doing HTML reports, which you probably learned about already in lesson 3, I need to use knitr. So I would check this, and that's one way to make sure that I'm able to access those functions available in the knitr library or package. And then what happens is this command library is actually executed. Okay. Now I can do a few things. When I'm writing code and I want to make sure that I'm referencing the right library, I can say require, and I could say knitr, or I can say library knitr. Okay. And that essentially, both of them essentially check this box for you. Okay. So just so you kind of know the difference. But when I'm writing a script, that script's going to be executed all at once, and you may not want to be so dependent on it running within RStudio. You just want it to run as an R script. So you need to be explicit about some of the actions that you do, like checking a box here by writing it in the code. Okay. Cynthia, I am going to talk about workspaces during the next live online meeting. But you can create your environment where you do keep certain things that are checked, and you can actually create a project for your work within RStudio. So you see I have a project here. I have one called Becoming Visual, a little plug for my book. I'm writing a new book on visualization. So you guys hopefully will be able to preview that in my Data Viz course in Shanghai in October. But I have a lot of code there that I'm doing as a package, and I want to set my environment up. So I'll show you how I did that, and just to give you a sense as well. Good question. I wish the book was available through Amazon Prime. I just have to finish writing it first, but it will be. And of course, you can get a signed copy, but you'll probably get the manuscript before it's actually published. All right. Yeah, I know. Thanks, Heidi. So good. So we've talked about packages. I want to go back to my PowerPoint presentation, and I want to talk a little bit more about where we left off last time about importing data. So how many people had trouble importing data from the live online meeting one? You could just say yes. Doesn't mean that you're still having trouble. It could just be that you've had some trouble. Yeah. At first, yeah. And most people able to resolve their issues? Okay, good. I've said this to some other students, but this is like one of those like hills that you have to climb, and then once you kind of get it, then it's really, really easy. Sometimes you just get the beta data in the bad format. It's just downloaded poorly for whatever reason, maybe not in Unicode format, maybe downloads in a different language. Maybe you've opened it in Excel and saved it by accident. So there's a lot of issues that can happen. But getting things working, if everybody's up and running now, that's great. I want to talk about two specific differences between these two functions on the screen. Can anybody share with me what the differences are? You can use your mic, or you can just type in the text chat. Okay, names format is one. One is from Readr, good. One imports data as a Tibble, yes. Heidi, Okay, so I want to make sure that everybody kind of gets this concept. Silly Tibbles, yes. Yeah, so a lot of the manipulation that we want to do on data requires us to use a data frame. Tibbles is a simplified version of a data frame. However, a lot of the functions of those libraries that we like using don't work with Tibbles as well. Okay, so you see the problem. So Tibble is a relatively new data structure developed by the folks at RStudio. It's in version 1.0. You can check out by doing !Tibble. You should be able to find something. So the read.csv is from the library utilities, utils, and this library is standard and installed with every version of R. Unlike read_CSV, this is from the library readr. So you can see everybody is providing an aspect of this answer that's correct. The newest version of RStudio uses the read_CSV as the default when you use the interface that says import CSV file. And what I mean by that, just to be explicit, so I'm in RStudio and I want to import data set. If I go here, I choose any of these, I say from CSV, it's going to import it as a Tibble. And you see the code preview below how it's importing it, okay? So that's just something to note. And if you go ahead and import your data like that, that's fine. You just need to cast it or coerce it, it's called, to a data frame. Okay, so this read.csv imports your R object, whatever data it is, as a data frame data structure. And we can always verify whatever data that we're using, what kind of data type it is, by using the class. which we learned last meeting. On the other hand, read underscore CSV is imported as a Tibble, which means basically a simple data frame. And it does have some advantages that I'm not going to go over every single one of them. However, again, a lot of the libraries we're going to be using don't operate well on Tibble. So we need to simply import it and then coerce it to make it a data frame. Does anybody remember how to do that? So say you import your data as a Tibble, and what if you want to make it a data frame? What would be the code for that? You don't have to have the exact syntax, but just if you have just like pseudocode. Yeah, you can use as data frame or you can use data.frame. That's correct. And then you want to assign that to a variable, right? So we would say something like, yes, I was just going to type it out, Tim, and you beat me to it. Love it. Good. Large X. All right, next. So recommendation for you, use read.csv just to keep kind of things simple. And this is the format for that. So if you just, in your R script, you actually code out how to read in a file. Okay, you write it out instead of using the button to do it. This would be the code for read underscore CSV. And you could also put those other parameters in. I think I have a typo here too. It should be double quotes. So any questions on that? I'm going to go ahead and we're going to review some things from the session 2 exercise that we started working on. And what I'll do is we're going to start by importing our data, okay, by using the read CSV, okay? A few things I want to show here. Our data is called data, so very simple, 26 observations of 7 variables. I can double click on it, and then I can see it, you know, very beautiful over here. And then I can go back to, I'm working in an R script right now, but we'll get back to how to create an R script. And then I want to do one more thing after I've viewed the data. I want to just check the class. So make sure it's a data frame. So class data, okay? And then it's a data.frame. That's what we want. Yeah, so John, you said, does read CSV allow you to set the variable name when you read in the data? Yeah, so you see this code I'm highlighting here. I can call this like, you know, pumpkin. I can name it anything I want. And that's almost the same as saying import data set here and changing the name here to pumpkin pie. Or data, whatever you want to call it. Or winter or. So let's undo that. And I will clear my console. Next, I want to go back to the slides and just talk a few minutes about our scripts. So one thing, John, you're asking, the variable type of the columns. It's not so straightforward. You might have to change those later. One thing that the Tibbles do really well is not converting certain types of data to factors. One problem with read.csv is most things are converted into factors that are categorical, that are perceived as categorical data that can be troublesome later on. So it's just a general response to your question. So R scripts. So Instead of typing everything at the console window, you can obviously save your work by creating an R script. It allows you to reuse your code. You can document your work, so you can describe in English or whatever language you prefer, actually, what your code is doing, what each line of code is doing. You can share your work with others, and you can move beyond writing one line of code at a time. So creating an R script is pretty simple. You can just go to the File menu, say New R script, and I just have some details here that when you create an R script, you'll notice that it's actually numbered, so you can actually know the number, the line number in which each piece of code is on. This is very helpful for debugging. That's why we care about line numbers, because your debugger will tell you, oh, on line 30, invalid object, something like that. You can use RStudio to execute your code, you can do it line by line by pressing the run button, or you can run the full script by using the source command. I'll just write that out, like source function, or you can quite simply just highlight all of the code and press the run button. Oh, James, nice tip. Yeah, totally. Okay, so we're going to start the practice exercise. We did one part of it where we imported the CSV, where we're going to learn about our data. This is following up to what was done in session 2, but we're going to do it through an R script, okay? So I'm going to go ahead and go back to RStudio. Quick thing on the R script, you used to say File, New File, R script. Okay, again, I mentioned that number 1 that's here, and this is the area where your R script is. If you save it, it will save to your working directory. If you haven't defined your working directory, it's just going to take you, to a default directory. So you can name it whatever you like, and it will have a .r extension, okay? And then you can begin typing, and using like a hashtag, you can put your name. You could put, something like the date, maybe description, and all this stuff will be ignored by R, meaning it won't be executed. So if I highlight it and I press run, it will just simply print out the text. It's ignored. It's not an executable code, okay? And then after that, I can start importing my data. So I can use my, I can import, I don't know if I'm doing Winter Olympics. What do we want to do? I think we want to import Winter Olympics, right? So you can begin by doing that, and then adding the rest of the information there. I've already done that, and I've called it data. So I'm up to this part. Now, if you haven't set your working directory, it's a good idea in your R script to set it, okay? And always have this command that always sets your working directory. So once you find it, you can just, and once you identify it by going to Session, Set Working Directory, Choose Directory, you choose it, navigate to your desktop wherever you have your files, say Open, the code gets executed below. You can just copy that and include that in your R script, so you never have to kind of do that again. And then above, write a comment that says Set Working Directory, so you know what you did. Is this clear so far? If I could just get a little feedback, just so I know. If I'm going too fast, too slow, please let me know. You're with me? One more time, please. Okay, one more time on the setting the working directory. Okay, so we use the set WD command to set the place, to tell RStudio the place where all of our files are going to be stored and saved, including our data files, our R scripts, etc. So when we create our first R script, we're going to save it, but it may not be, if I say file save as, it will go directly to my working directory. However, what if I haven't set my working directory? So first, we want to make sure that we go to Session, Set Working Directory, and then choose the directory where your data files live. Where does the winter underscore CSV live and the March Madness data set, these PDF files? Pick one place on your computer and navigate to it, and that will be your working directory, at least for this program that you're writing. Okay, and then you say open, and you see down below in the console window, essentially that set of clicks generated this code, which gave me the full path of my working directory. I go back to my R script, and I type that command in, so I never have to kind of do it again. And I say setting working directory. Okay. Now I can save my R script, file save, and it's going to be saved automatically to my working directory. So next, I can work towards importing my data. And we're going to use the read CSV function. I'm just navigating between my full script and the one that you're writing. So the next line, you might have something like this. So again, you're adding your documentation along the way using the hashtag. Okay, so the next thing is we want to open and look at the data. So to look at our data, we can use a command that's a view command, and we can type that in here in our script. So we're not executing, we're just going to type it in, and then we're going to say data. And then I'm just going to highlight this line of code on 11. I'm going to press run because I want to run that. So I see my data. Now I can only see my data if I've imported it, right? So I've actually run this line of code, and I can only get this if I ran this line of code. So everything needs to be sequential. So make sure you run these lines, and now you're on view data. Brings up this tab with my full data set. Hopefully everybody's able to see that. This view data command is very unique to RStudio, and we're only able to, if I highlighted all of this and ran it, it would work perfectly. If I tried to take this code, which we know works, right? I can highlight the whole thing and I can press run, and I get everything. Every line works. And I like to, when I teach programming, like to show line by line. But let's say I wanted to create a HTML document or a report from my R script. Has anybody done that yet? Has anybody created a report? Yes. So I'm going to show you what happens. So when you create your report, you usually go to Compile Notebook here. And I'm not asking you to follow along. I want to show you something that's important. So you go Compile Notebook, Report Output Format, and then you can choose HTML or Word. PDF requires a latex package and several other packages that might not be worth you installing. So I'm just going to choose HTML. I say compile. And look, I'm getting an error. And the error looks like it's on, line 3. It's kind of very cryptic. So this error is caused by this line, view data, right? So if I comment this line out, and then I do the same, save it, and then I do this, and I compile my notebook again, you'll see that I have my first R script. And now I can take this and I can go ahead and publish it on RPubs. Just want to show you the whole process. It's uploading my document. Usually have to create an account. I have one already. So now everybody has access to this very sophisticated program. But being able to publish your work and create reports is really important. And I just wanted to show you the whole process. And this is every time you get the solutions from me, they'll always be as an RPub, so you can always see them online. But why I'm showing you this is because this view data does not work when we try to compile our notebook to create an HTML file or create what's called knitr. So this view command is only reserved for working in RStudio. So if you want to just look at the data, you can simply just say data and then run that, and you'll see the data here. Okay. That was a long explanation, but it's an error that you might not be able to decipher. So I wanted to bring that to your attention. If you are having problems importing the data, go ahead, open in Excel, maybe remove some of the funny characters that you may see there. That's what people have done in the past. Another thing is to re-download the document and try importing again. You can also try importing it as a Tibble to see if you have better luck there. But it seems like some people are having this kind of issue. I get about like 4 or 5 people that get this error that I just typed in. Not today, but just in general. So it could just be something about, you know, how it was downloaded, the environment, how it was converted, and then you kind of get something funny. So you might have to actually go in and manually remove those funny characters. Because you don't see them here in my file, right? And I'm using the same data as you. Okay, so I'm going to take a moment. It seems that my Go to Training Control Panel has frozen up. Maybe after I've typed in that error code. I hope that you can still hear me. I'm looking at the text chat right now on my phone. Okay, good. Thank you, Tim. Thank you, Heidi. You can hear me. So I'm going to go ahead and go back to the session 3 exercise. So after we take a look at the data, and again, I like to comment out that view data. The next thing is, you know, how many variables are in the data frame, and we can use this line here to see how many variables there are. Okay, and that just basically means columns. Okay, so if we're using the length function to do that, and you don't have to. This is just making it super explicit that I'm actually printing out the output of the length function when I pass in the argument, which is our data frame. I can also learn the names of the columns. So if you're following along with the PDF, I have those, all of this written out for you. Okay, and that's helpful. And you'll say, well, I could just look at the data. I know the names of the columns. However, you might want to change the names of the columns. You might have so many variables, you know, like I'm working with a data set that has like 142 variables. I can't possibly see them all on the screen. So that's another thing to consider. And then we can also look at the entire dimensions of the data set using the dim function, DIM. And here we're seeing that we have 26 observations of 7 variables. So that can be helpful. And there are many, many other functions for interrogating your data. The str function is a good one. So you can put that in your script, str data. Right? And so here I get a lot of information. And I get 26 observations of 7 variables. I see all the variables. Anything with a $sign next to it represents a variable. And the type. So you know that rank was imported as an integer, NOC as a factor variable, integers, region as a factor variable. Now, factor variables, what do you guys think about them? What are factor variables? Categorical categories, okay. A cross between numeric and characters. Well, almost has both, right? It has numeric and characters. Heidi says assigning numbers to values. Or categories, really. Good. And so there's a few things to notice when what I have on the screen here, and you can just type out the str, use the str function as well. But it might make sense for something like region to be a factor variable. Because it's a factor with 5 levels. What do you mean by that? What is a factor with 5 levels? I'll look in the text chat for some answers. Only 5 unique values or groups. Okay, I like that. Good responses. So let's go back just to look at my data. Just visually look at it. You see it on the screen here on the upper. And you see region. I have Eurasia, Europe, North America, Europe, Asia, Australia. Okay, so there are only 5 possible values that can be assigned to any one of these observations. Okay, so that means I can do a lot of grouping with region. I can say, show me all countries that are in Europe that are, ranked top 25 or 26 in the Olympics. So I can ask better questions when I can kind of categorize it. Okay. And each of those is assigned a number. Okay, and then we can actually do math on factor variables as well because they have numbers associated with them. Those numbers can be assigned, or you can actually they're put in by default 1 through 5. Okay. So if I typed in something like data $region, what would print out would be actually every observation for the region category, so the entire column, and then you'd see the levels. Okay, so the levels are those unique values, only 5. What's the issue? Let's go back to str. And what's the issue here with NOC being a factor? If you have an answer, you can. All levels are unique. It should be of type character. They aren't groups, all unique. Yeah. So that's just something to consider. And we could always change that whole column and create it as a character using the as.character function. Okay, so you can feel free to go and do that. But so if I just go to data and OC, you can see it has 26 levels, right? A unique level for every single country, every single observations. So this is not a good use of factor variables, even though it's a factor, and but there's really no really meaning behind doing that. Okay, so that was just a little bit on factors. I'd like to discuss that since we are interrogating our data and using functions like read.csv, and just want to show you some consequences of that, intended and unintended maybe. So I'm moving on to the next question, which is to print the mean of gold, silver, and bronze metals. So this is basically, we're just taking a mean of a whole column here, okay? And so let me clear my console. And again, I just highlight it and I press the run button. So I write my code here first, make sure I don't have any typos, and then I would run that line. Okay, so I have my mean of the column gold, silver, and bronze. You can kind of say, is there any real value in calculating the mean here? Perhaps the sum might be more meaningful of a number, so we can use the sum function, okay? And again, this is our data frame called data, and we use the $ to indicate we're referencing a variable here. And we can take the sum of the gold metals, the silver metals, and the bronze metals. It's case sensitive, so if you type lowercase b for bronze, it would be wrong. If you're sick of kind of writing in the name of the data set and $, then the variable name, one thing that you can do, which I'll show you on line 41, is use the attach function. So you can attach a data set and you say data. So I would say that. And then I could say simply, sum bronze and get the sum there. And then once you're done using that data frame, you can use detach. You notice how I start typing, it comes up with the information about what parameters I can pass in. Okay, any questions here? Okay, so let's just do a few more. I just want to get to the subsetting, and then we're going to begin working with a new data set. So I want you to print a list of countries that not win each of the 3 metals, and print countries that not win each of the 3 metals, the number of countries. So list and the number. And we can do this a few ways. I have a simple way shown here, so you can work with that code, where I'm using a function called subset, and I'm literally, the parameter is x, and I'm passing in what? My data set called data. And I am taking only a part of that data set, and I'm subsetting it based on a few conditions. That gold is equal to 0, silver is equal to 0, and bronze is equal to 0. So once I run that line, I can actually view that, and here are all my countries. So if you read the question carefully, it wasn't countries that won no medals. It was ones that didn't have all three. So there should be at least 1-0 for either gold, silver, or bronze. And I can use the length function to see how many variables I have again. And I could also do str, dim to medal subset, right, to get, I have 8 observations of 7 variables. So good question, Tim. So we use the pipe operator as an OR. And sometimes you have, I'm going to be typing in as a different person because I just wrote something as a student. That's me. In other programming languages, you use the double pipe that I just wrote here instead of the single pipe. All right. So everybody good with this, these concepts? So purposefully, I'm using some old data from 2004 of the March Madness, but in here, I actually have the link where you can download the new data if you want. Don't do it as part of the session, but if you actually wanted to run this script using the new data, that could be like an interesting exercise that you can do for yourself, okay? Oh, thank you, Carlos. That's a good point. So I have a set of instructions for you, and why don't you get to it and then share some of your code with us. Specifically, questions 8 and 9. So basically, I want you to import the March Madness data set, view the file, print the number of rows and columns, and I want you to do this as an R script, okay? Change the column names to lowercase, and I kind of tell you how to do that. Okay, so sometimes we want to change the column names. Explore the variable types using the str function, and then answer the 2 questions. How many different conferences are there? And then question 9 is, what are the difference in values of the first 2 columns? And I kind of give you a hint of how to approach solving that. And then I'm going to go over how to solve it. But you're going to need some time. So I'm going to give everybody 10 minutes to work on this. And I'll be around in the text chat and online for questions. But let's return at my time 1:08. So Mark, you're not able to download the file? Is that the issue? If you go to materials, you should be able to download, or you're just having... Okay, so Mark, anytime for future reference, like with these live on-site sessions, there's a materials area in your Go to Training thing, and you usually get emails from Go to Training that tell you the materials to download. But in addition, when you're in NYU classes, I'm just bringing up on the screen so you can see where to find everything. I know you guys are taking lots of classes, so I don't expect you to memorize everything, but I like to show it to you so then you know in the future. So you're in NYU classes, you're in this course, and then there's an area called Materials for Online Sessions 1 through 3 under all the lectures for the R portion of the course. You click here, and then here you'll see session 1, 2, and 3. And here we're working on exercises 3, and we'll see how far we get, maybe 4. You can download the data here and even the solution. So I hope that's helpful, Mark. Great. I'm just taking a look. Ooh, yeah, I see some really good. Yeah, great. So using the absolute value function, that's great. All right, we have one more minute or so. I think I was going to give until 1:08. So. It's 1:09, so I'd like to review the example with you. How many people are still working on it? There's like 5 or 6 people who shared their code with me, and the rest haven't. So I'm assuming you're probably working a little bit. You're still working, okay. So I'm going to review it and just make a note to yourself in your R script where you stopped and where you're going to continue. Thank you. Some people are also sending it to me as private, which is totally fine. It just means that no one else can see that. And if you want to do that, that's great. Okay, so we're going to import our data set. We're going to call it March Madness. I'm going to use the read CSV file function. When I do that, I see that I have an observation of 349 observations of 9 variables. So our data is a little bit bigger. I'm going to just take a look at the dimensions of my data too, even though I can see it in RStudio over here. I like to always print that out. It's going to clear my console. Then I'm going to get the column or variable names using the names function. We see that everything is uppercase. That's kind of a pain to deal with uppercase, especially when we start doing, you're starting to create reports or visualizations or presentations with the data, and you want to use the variables. Sometimes you don't want it to be in all caps. And so it's just nice to kind of change it. So in this case, I'm going to use a function called toLower. And so this is a function within a function. So I'm going to take, you saw that the names function returned the names of each variable. And then I'm going to pass that in as an argument to the toLower function. Okay? And I'm going to assign that back to March Madness, the data frame. But I don't just assign it back to March Madness. I have to actually pass March Madness as a parameter. Okay. So we'll do that. I'm going to run that. And then I want to check to see if it worked, right? So I can use the str function as an example. And you can see that it has worked. And my data frame has been updated. Now, is my CSV file updated at this point? No. How would I update my CSV file? Write.csv. Thank you, Carlos. Excellent. And now everybody's going to want to do that. We're not going to take time to do that now. But if you wanted to learn how to do it, you would say write.csv, and you could find more information in the help area. Okay. And you could see some examples there as well. Given write, Excel file. Doesn't only have to be CSV files. Great. Questions so far? I don't see anything in the text chat, so I will move. So now I'm going to go ahead and compute the differences in ranks and create a new column in the data frame. My March Madness one, okay? So right now I have 9 variables. I'm going to create the 10th variable. So first how I create a new column is how I name my variable. I have March Madness $diff. This variable diff does not exist in my data frame, right? So let's just go and look at our data. It doesn't exist, right? I don't see it here as a column name. What I'm doing is actually adding a column to my data frame. And I do that by using the data frame name, $, and the name I want to give that new vector or column. And then what values do I want it to contain? Well, I want it to be the result of rank minus previous here. Okay. So let's do that. And then I want to go ahead and create a subset where the difference in rankings is greater than or equal to 3. So let's look at this code carefully. We use a subset function just like we did in the previous exercise. We pass in our data, X, which is March Madness, and we're taking subset. So we're saying subset on what condition? Subset equals, right, and here's our condition. The absolute DIF, difference, that new column that we created, is greater than or equal to 3. Why are we using the absolute function, the ABS function? Good, Heidi, right. So it could have gone up 3 places or down 3 places. And so if you remember from our first online meeting, you probably thought it was silly that we were just taking the absolute value of like the number 88, if you remember. You're like, why are we doing that? But this is a great way for us to simplify what we write, our code. Instead of, I think some people wrote it out a little bit longer where they said greater than or equal to 3, 3 and then, or -3. So let's go ahead and do this. So I have my subset. Notice it created a new data structure here, my subset. 9 observations of 10 variables. I can get my dimensions of that subset. I can print those dimensions. And I can see those 9 observations and what the difference has been in terms of places. -3s, -3, -3, 5, -5, 6, -8 places. Okay? So we kind of did a lot of work here on manipulating this data set, and you could, this subset you could even write to a CSV file using that write.csv if that was the objective. Okay? And Cindy, I see your question. You don't mind if I read it out loud. Would it be wrong if I create a variable diff equals C? No, it wouldn't be wrong. You just would then have to, no, that wouldn't be wrong. So we're talking about how we're creating that variable called difference. But I did it all kind of in once. I added that variable to the March Madness data set in one shot. So I hope that's clear. Good, good, good. Well, this concludes our work on the session 3 exercise. And like always, I have another exercise for us to work on, and you're not intended to finish it in the next 12 minutes. But it's to kind of motivate you to continue working. And we can start on it, but I just want to, I see Bharath has a question on naming a variable. So what's your question, Bharath? Okay, while we wait for his question, and I see there's another, Tim, you have a question. Are there sources for these types of exercises that you recommend? What do you mean by that? Like, are there more exercises that you can do? I guess a smiley face means yes. Oh, okay, cool. So, gosh, there's so many more exercises that you can do. I'm trying to think if there's like one resource. I mean, once you start becoming, Kaggle is great. GitHub is also a great place to go. RStudio their website has a lot of great examples and little tutorials that you can go through, Tim. So I'm just going to bring that up. And if I go to rstudio.com. And there are a lot of, like, say for instance, you wanted to learn about Shiny. You can go here and learn more about that. And there's some tutorials here that you can go through. But this is a great resource if you just wanted to check that out. A lot of times the practice that you're going to want to do is related to a package. And maybe that package might be, and these are all ones that we learn. You can see that there are so many. So it really depends what your objective is. If you just want to do more practice at this level, then I can send you some tutorials. So I also got a question about reserved words. So I use question mark reserved. And here are some of the reserved words in R. Okay, these are words that you can't use to name your files or variables. Okay, and data is not one of them. Okay. Yes, and I've created my data frames. I just use the word data. It's not good practice. You want to use something that's much more descriptive. I do that just because it's just easy when teaching to call it the data instead of say winter or March or something all the time. So for simplicity, but you'll notice as we progress, I'm going to start kind of weaning everybody off data and calling it the name of the data frame, that it would be more descriptive. Any other questions? These are good. These are good questions. So why don't we go ahead and open up the PDF file for session 4. And I just want to review it with you and give you a few minutes to begin the work on it. So we're going to go back to the winterolympic.csv. We're going to get to know our data, which you've done probably a lot now, so you don't probably need to do step 1. And then we're going to work on some sorting. So the data right now is currently sorted by rank, and we want you to sort it by data and total metals and country, and then assign the sorted data to a new data frame. Then you'll interrogate that data by using the describe function to look at it. And this is where you might have to make sure that you reference the HMyths library, because that's where the describe function comes from. So I'm just running down the question just to give you an overview. Then we're going to look at some very simple summary statistics. Looking at the median, we'll also be looking at the mean. And other statistics that were very simple, like the min and the max. Those things are really important. You'll probably be using that a lot. Standard deviation, skew, and in using some of these, you may need to install the psych library, okay, for the summary and describe function. And then you'll move on by subsetting, doing some more exercises 6A through E. I have some questions there for you, looking at the max and the minimum, so that's always an important thing to do in programming. And then we'll finally look at some correlations. So why don't you go ahead and begin by, you probably don't need to do question 1, by doing questions 2 through 4. And I'd like you to get through questions 2 through 4 if you can in the next 5, and in the meanwhile, I will answer some questions. So Cindy, I see your question. So maybe you can share a few of the lines of code with me so I can see what you actually did. because you should see a column that looks like this that I'm highlighting here. It's not because you didn't do right CSV, but why don't you first tell me if you see it in B-ball? That's where you're adding the new column. Okay, so yeah, I'm looking at your code. I mean, obviously there's nothing that I see that looks wrong, but that first line is where I'm worried. So you should have 10 columns at that point. So what I'm going to do is I'm going to take your code and I'm going to, this is what I like to do, Cindy. I'm going to put it right under here. And we're going to look at it because, and I'm going to just do, I'm going to change a few things, just the names. See if there's something that we're not seeing. I'm getting an updated. You can see I'm getting diff 2. So you should be getting that as well. Okay, well maybe you can send me all of your code, but I don't see why that wouldn't be the case. Okay, so just to review a few things from session 4, I didn't see anybody typing, sharing their work because I'm sure that it'll probably take a little bit of time to work through the exercise. But just to give you kind of like a head start, I wanted to bring up the a few things. So we can sort the total metals and country using this order, okay, function, and we can sort our data based on that. So let's run that, and I can show you where how I'm able to sort there. So again, I'm sorting by total metals. Okay, instead of sorting by rank. And it's doing the smallest to largest. And then we can use the describe function to say describe our data. This is a great function, obviously, where we can see all the number of observations, which all should be equal. So you should have equal lengths of your columns. The mean is already calculated, the median, the trim mean, the maximum, the minimum, the range, and also the skew. So this saves you a lot of work instead of writing out each of those functions at once. And you can go ahead and work on the rest on your own, and let me know if you have questions. And I can even review some at our final third online meeting. So, because it's 1:31 now, and I know some people have to head out. So thank you so much for your participation today. And I'll stick around for questions. But at this point, I'm going to stop the recording.